of the interesting things, the more fans you pick, it actually takes more time to pick fans, because you'll learn some lesson along the way and you'll second guess yourself and go, well, maybe this one might be better. Maybe that one might be better. So this is just a template for thinking about fans versus doing it. So that's the 30,000-foot fan selection view. All right, so here we go. If you are a newer engineer, and you, granted, it's not 1992 anymore when I got going in the industry, but you started off with a book. You open up that book and you go, oh my God, there's 1,000 fans in here. How am I supposed to disseminate what's the right fan? So you figure out, you know, power roof ventilators are pretty durable. So you go, I'm familiar with the ACEB or the GB or whatever fan you use. And then you figure out an inline model to use, and then away you go. That's, you know, the whole, if the only tool you have in your hand is a hammer, then everything looks like a nail. So we want to make this thick book a little bit thinner by narrowing the selection. So with that, how do we cut down the catalog size? Number one, what wheel? Let's start off with the wheel, okay? And there's more wheels than probably, there's lots of names for wheels, but the actual number of wheels that you need to consider is very small. And here's a hint, there's 3. Then once we get the wheel kind of ironed out, let's figure out what kind of box we're going to put it in. And finally, what's going to be driving the wheel and where does that driver go? So if we can start off with those 3 things, the catalog shrinks a great deal. Okay, so let's talk about fan wheels. The most common fan wheel for, certainly for the fans that we deal with, is the centrifugal fan. Upper left showing you, you know, you guys have heard about airfoil wheels and flat blade wheels. They're basically the same thing. Software is good enough where you can pick an airfoil wheel and a flat blade wheel at the same time, so don't even spend much time thinking about it. The wheel is centrifugal. It goes in the inlet and out the side. And if you're looking along, there's a picture of a fan curve here. Now, I'm not going to spend a lot of time on the fan curves because this is not exactly a basics class. But what I do want you to pay attention to is, here's our axis that has the air volume, and here's our axis that has the static pressure. So a stable curve is one where a small or reasonable change in static pressure is not going to result in a lot of change of airflow. So this fan is at 5,000 CFM at 1/2 inch, a very common building fan selection for relief. So if we have a bad fitting and we jump to 0.7, how badly is our airflow affected? In other words, how much more horsepower are we going to have to put out to manage that? In the case of a steep fan curve, it's created by a centrifugal wheel. It's very small. So if we go from 0.5 to 0.75, you know, our range here is just a few hundred CFM. And that's the important thing to think about as you're deciding the centrifugal wheel. Now, the other side of it is centrifugal wheel requires a fair amount of energy to take the fan, or I'm sorry, to take the air coming in and turn it 90 degrees, throw it against the housing, sometimes for like an inline fan, and then turn it again. So the horsepower impact for a centrifugal wheel is a little bit high. All right, there's one wheel. Wheel number 2. A propeller wheel, an axial wheel. There's a lot of different versions of it. Every fan manufacturer has their sort of basic prop, and then their fancier prop, and then their aluminum prop, and then their extruded aluminum prop, and they all do a little bit of different stuff. But at the end of the day, what is the, you don't need to know all the props. That's sort of immaterial. Some are going to be a little bit better at a higher static, some are going to be a little bit worse at a higher static. But look here at the curve. So we talked before about a 1/4 inch change resulting in a few percentage points difference in airflow. Here we start off at a 1/4 inch, and if we go to another 1/4 inch, we cut the airflow in half. Someone's at the door. So the thing to note about propeller wheels, number one, the amount of energy to move a lot of air is low. The amount of impact of static on a propeller wheel is high. So it depends on the kind of, I guess I'd say, resolution or authority that you need over this fan will guide whether you need to select it. I've seen a lot of, I don't know if engineers use single fans for building pressure relief anymore, but think about it. What does it take to relieve pressure out of a building? Not a whole lot of static, but yet they use centrifugal fans sometimes, in the form of a PRV, when a propeller fan would be far more efficient, use a lot less horsepower. So it's another tool in the toolbox. And finally, this is our hybrid wheel. Now, it seems like I often talk to folks where mixed flow wheels are sort of a new thing. They've been around for like 15 years. And this is such a great image of a mixed flow fan. You can kind of see it sort of looks like a centrifugal fan, and it's been squashed halfway to look like a propeller fan or an axial fan. And the curve is sort of accordingly. It's sort of halfway. It does have excellent resolution when it comes to controlling static versus flow, but because we're not making as significant a change in the airflow direction, it's pretty good on sound, and it's really good on horsepower. So you can also see that there's a lot to this fan. So cost-wise, it gets to be a little bit expensive. You don't want to throw, even though it may be the most efficient fan for an application, you may be throwing dollars that don't pay off. So I made a little matrix, and it's in your, if you didn't get the email with the PowerPoint, this is in there. So just a real quick cheat sheet. First cost, propeller's cheap. It's just a prop and an inlet. Mixed flow, the most expensive, centrifugal in the middle. Operating cost per CFM. Centrifugal is going to be the highest. Propeller is going to be the lowest. Mix is in the middle. How about how much control you have over the fan? Centrifugal may be the best. Propeller, not so much. And mixed flow is very good too. And when are you going to have sound issues? Centrifugals at high pressure are going to create a lot of noise. And we see these in these little bitty fans that have 400 CFM, and we're trying to get an inch out of them. You wouldn't believe the amount of sound that comes out of these things. And when you push the envelope on a propeller fan, that's when you get into some really impressive sound levels. You go, oh boy, I didn't realize I could generate 80 zones on a roof line. So, and then mixed flow is sort of fits into both if the project calls for it. This is rough. This is rough. So we're going to go through some different examples and talk about it. Okay, so now we've talked about the wheel. Oh, before I move on, any questions? Or you can put it in the chat box, and Bob will interrupt me if this should be pretty straightforward though. If you've been around fans long enough, you should not be surprised. All right, so now if we know our wheels, we know that we have a higher static application. We're ruling out props. We're putting in a centrifugal. Maybe we're thinking about a mixed flow for the right thing. Let's put it in a box. Well, I see a lot of applications where power roof ventilators are used for, let's say, and there will be an example, summer ventilation. You can put up about twice as much air through a hooded prop as you can with the PRV with the same horsepower. So the PRV, the centrifugal wheel, is great for generating static. If you don't have static, don't use the centrifugal wheel. Use a prop. And you saw there's lots and lots of versions of props. You can get it dialed in just the way you want it to. That's down blast on a roof, up blast on a roof, all versions. Here's your propeller versions. Here's your centrifugal version. You can even get it in mixed flow. Now, something to pay attention to here, which the books don't always do a great job. If you're willing to do service from below, this fan may look to be a better performer. It doesn't have all the, it's got a tighter motor assembly versus hanging the motor off to the side. But if you're not careful, you end up with a fan selection where your motor is over a piece of equipment in the plant, and someone at the owner goes, "What did you give me?" So that's where is the driver located? One of those considerations. Have I seen it missed? Seen it missed. All right, now we're into the, I guess, more traditional air handling type with centrifugal wheels. This is a single wide scrolled housing, single wide plenum arrangement, double wide centrifugal arrangement. So only difference is you got two inlets. And then you can put the fan in a box. You can put it in a barrel. So here's our mixed flow fan, which is generally always in a barrel. You can put a centrifugal fan inside a barrel or a box. You can put an axial fan inside a barrel or a box. And finally, you can put them on the wall in a square box or a centrifugal on the wall. All right, and that's easy. So figure out your wheel, you figure out the ideal mounting situation for the fan, and now you've got most of the work done. Finally, the drive assembly, and this has gotten to be a much hairier business. Well, let's see, 10 years ago, you would select a little fan to be direct drive, and anything big was belt drive. Now we've got way more options. And this is a good visual to kind of think about, okay, which way, so this is a PRV with the dome taken off and the wheel taken off, okay? So here's our traditional belt drive assembly. And that works great. Most of the time, this is what we're putting in. But now there's a lot more push for, well, maybe I don't feel like servicing those belts and pulleys. Well, we can go direct drive with an induction motor. So the difference, so if we draw a line here, this side has induction motors. Induction motors work with standard VFDs. So your ABB drive, we sell a drive, Yaskawa has a drive. They work with induction motors, okay? One thing to pay attention to, if you're doing lower RPM fans, the induction, and you're gonna go, well, let me back up. Most PRVs, for example, have RPMs in the 400 to 800. Well, with belt drive, you just put a different pulley set on it and you can get the fan speed as low as you want. With direct drive, you really, for a lot of reasons, and we're not gonna get into it all today, you're not going to use a 1725 RPM motor for a 500 RPM fan. You're going to use an 860 RPM motor, which is closer to the max RPM of the fan. The trouble with this is an 860 RPM motor costs 2 to 3 times what a 1725 RPM motor. Do owners know that? Owners who say, I don't want any belts, they probably don't know they're paying double or triple for that motor. And if we're just pricing it up one way, we don't know, but this is just one of those things to be looking out for. Now, if we're in single phase and we're going to go to a permanent magnet motor, it's traditionally called an EC motor, an electronically commutated motor. Or if we're going to be, oops, sorry about that, in 3-phase, this is called a permanent magnet motor. This is readily accepted now. What's nice about these is we can program the motors for the maximum horsepower, maximum RPM, whatever that turns out to be. So in the case here, if we wanted a 500 RPM motor and we wanted a 1725 RPM fan, so it didn't cost a fortune, we could program the maximum RPM, but we can't do that with the 3-phase motor yet. With this motor, we can program it to whatever horsepower we want with a cap on it. With this one, we can't. So at some point, we'll be able to get 1725 RPM motors slowed down to the speed that we want them to. But for now, the RPM's low, permanent magnet and direct drive motors get to be very expensive. If you have a fan that's running at 1500 RPM, hey, you're in business, 1725 is perfect. There's not much of a premium. It's these lower RPM motors that do. So that's frankly a whole other presentation about drive assemblies and different motors, but it's just something to think about. Lower RPM, higher cost on the motors if it's direct drive. Okay, And would I want belts and pulleys to service? I would not, if I can choose not to, but I would not have known these things had I not really done a little bit of research on it. Okay. What's cool about all the software programs, if you become a little more experienced with them, is you can do a multiple selection. So if I'm looking at power roof ventilators that are belt drive, I can also at the same time look at direct drive with electronically commutated motors by simply hitting the control key. I don't know how CAPS works. I don't know how the other guy's software works, but it's pretty easy with cookware. Just tap on the control key. I often look at multiple fans at the same time, narrow the selections, then go back for more detail. And I'm going to show you some examples of that too. All right, moving on. Now this is more of my spin. You're not going to necessarily get this if you go to a fan basics seminar. This is stuff I'm looking for. I am, after picking as many fans as I have and getting in the middle of lots of little fan problems over the years, become a little paranoid. And so you can use the software to keep you out of a little bit more trouble if you know, just to have a couple more ideas. Here's one. If you pick a fan, and let's say you're not looking at this do not select line, which often you will see submittals without a do not select line. By the way, before we start, does anybody know who decides where this do not select line goes? And since most of you are just in listening mode, you can put that line wherever you want to. So Cook could take this line and move it over here and have a lot more selections be stable. Well, this is just completely an arbitrary line. We've picked the same fans as competitors, and ours is listed as unstable and theirs is listed as stable on the same spot of the curve. What you are looking for is small changes in static leading to big changes in CFM. I would not call this 330 QMX. I wouldn't call it particularly stable. What's it going to take for us to jump over the curve? Bad fitting? So I look at, I like to be closer to the max RPM. I like to have a longer way down. This green line down here, that's the minimum fan RPM. Does that mean that it won't work below that? No, it just means that that's where the fan manufacturer stopped testing. I like that they tested down to 4,000 CFM on my fan that's 15,000 CFM. I know I'm going to achieve the turn down that I need. Here, I've had fans that go across the do not select line as you turn it down. So this gap makes me happy and feel safe and sleep better at night. What am I giving up? Few dB. How much? I don't know. If you attended the silencer class, we know that silencers are cheap. Let's buy a silencer. Okay, enough on that. This is what I would call authority. What's the gap between my selection point and my minimum RPM? What's my gap between operating point and the do not select line? Is this a stable curve? It is, technically. I wouldn't want to use it though. All right, next one. Did I skip twice? Okay, is the sound manageable? Okay, I've said the best way to move a lot of air is with a prop. This is a prop with a butterfly housing. Careful, 77 zones is really, really loud. We're into hearing protection. Our decibel or dBA is over 85. Same fan, same setup. Sometimes you're stuck with what you've got. We switch to a mixed flow, same performance, same horsepower, same motor horsepower, different tip speed, but we've dropped from what? 91 to 82. We don't need hearing protection anymore. A barrier wall would work if it's got a neighbor nearby, that kind of thing. All right. This is a big one. Is the static over or understated? So, and we'll talk about this in a little more detail. With this fan, is it okay to put 0 as the static? Or should you put in your 3/8 like usual? Well, it makes a big difference in the performance. We go from 56 zones and hearing protection to 36 zones and something that's a little bit more manageable over your, I always put in 375. you may not need 3, and we'll talk about this a little bit later in more detail. Okay. And Mark, I'm not sure if Compute-A-Fan offers wheel width selection, but you can increase this gap between your do not select and your operating curve with a reduced width wheel, and I'll walk through an example of that a little bit later. And then finally, and maybe the biggest thing to consider is what's included in the fan test. So when you get a PRV and you pick it with the cookware, and you put a backdraft damper on it, is the static for the backdraft damper included? Well, according to this chart, it's not. At 1,000 feet per minute, it's like 0.22. So you should have extra static. If you use the center pivoted isolation damper, the pressure drop's not nearly that high, but this thing has a big frame on it. And does it take into account the elbow that's before the fan? Not necessarily. So knowing what's included in the fan test and what's not is really important. All right. And this is the small print. On every fan page, when you use the book, it says this: does not include transmission losses, which is the loss of belts. Does not include pulley losses. Does not include the effects of appurtenances or accessories. So you have got a fan in an ideal lab condition, and your fan will never be installed in an ideal lab condition. So you need to make provisions for that, and it may be beyond what you calculate with your software. All right. So let's open up the software. We're going to look at that 15,000 CFM. I put some fun stuff in here. The mechanical room is extremely tight. So what does that mean? Well, one thing is, at 3 inches, can we rule out a prop? Oops, sorry guys. Can we rule? Absolutely. Props are gone. So now we're talking about a mixed flow fan and centrifugal. I know that when people pick return fans, they generally think of what? A straight through fan. But can you get a 90-degree turn and save yourself some system effect in your mechanical room, especially if you're already going to put elbows in? We're going to take a look. Okay. So what we could do is look at inline fans. Select, and let me just zip through this real quick. You can pick by application. Oh shoot, it's going to pop over here. You can select by app. Don't do this. This is a waste of time. You can select by, if you know your sales guy's products by number, you can select by model. So ACEB is a belt drive power roof ventilator. You can select, and we're going to do this today by, what is it, by group. Yeah, we're going to select by group. So let's say we're going to look at inline centrifugal blowers belt drive. Whoa, that's just about, there's a whole bunch of selections here. So an SQN is a box fan. Some of these are more like Ford curve fans or little bathroom fans, but they're still inline centrifugals. CIC we haven't sold in years. This is the old Centravane. But I can pick all this, put 15,000 CFM at 3 inches, and the software can just do my work for me. I don't have to look through the catalogs, and I don't want to. All right, that is a whole bunch of selections. And let's sort by horsepower. Well, it sure seems to like these mixed flow fans. So until we get to this 36-inch inline centrifugal at 11.9 horsepower, I can pick several sizes smaller of QMX fans. So I'm going to rule that one out. And as we keep going down, there is one fan I want you to take a peek at. All the way down here. This is an inline centrifugal. It is louder. It does have a higher horsepower, but you can take a box fan, put the side door on the end cap, and turn it into an elbow fan. So if that gets you out of a couple of bad turns, you may make up the difference for having an inline fan. So let's narrow down our choices. We like the QMX fan, and we're going to take a look at this box fan. And then one other fan that has a right-hand turn is a centrifugal. So now we're going to go back, and we're going to select by our models. So we saw the mixed flow fan was a QMX, and we wanted to, just because I'm pushy, we're going to look at that box fan, and then we're going to look at a centrifugal. Now, if we were to add direct drive motors into this, it would create a lot of complexity that we don't necessarily want. Let's figure out what the right fan is. And if we really feel like monkeying around with belt drive, direct drive, we can do that on a different show. All right, so we're back, 15,000 CFM, 3 inches. Someday Cook software will be online and I will be very happy about it. Now, we saw before that box fan, 15 horsepower, 14.7 horsepower, 29 zones. It's one of the loudest fans here. Would that be a good fan in light of what we can do with using a CPS, which is a 90-degree fan? You go over here and look at the detail. I probably should have made it top horizontal, but you can see this is the inlet side. We can rotate this housing 90 degrees and make it, the air come in the side and leave at 90 degrees. That may be a better way to go. So I think what we can do is show, all right, a 30-inch CPS versus a 40-inch inline centrifugal. I think we're way better off with the utility set. So now we can look at these CPSs and we can look at these QMXs and see which one's better. Well, and you can also look at the curves quickly. So this one I'd say probably too close to the max RPM line. Next one. Oh, that's a really good, that's good looking curve. Do I like the sound? I'm looking at that outlet sound on octave band 3 and I'm going, it's something I'm going to have to deal with. At anything over 100, you're going to need to pay attention to. High 90s, you're going to need to pay attention to. This is on the inlet side. At 98, you're going to need to put silencers on the inlet side. All right. So let's look at if we go a little bit, maybe I'm not liking the turn down. It's pretty good turn down. I'm at 15,000. I can get down to 5,000. Plenty of turn down. How did I do on my sound? I don't really like these numbers still. So let's take a look at our QMX fans. Whoa, big drop. Big drop. So is it worth it in this case to go dig up, if we have to put an extra elbow in, we're not going to get the elbow out of the fan? Absolutely. Those numbers are really, really manageable, maybe manageable without a silencer at all. So we could look at the high pressure QMXs to see if it's better. We're at a 270 standard 10.4 brake. Let's see what the high pressure wheel does. The high pressure wheel gives us more gap between the two, but it also raises our sound levels into the 90s and octave band 3. So somewhere between, not that one that's on the max RPM curve, that one's not bad. I think that one's really good. So this is where I'd land, unless there was a reason that it couldn't fit. And so close. I'll just go through the process of saving the fan. This is what your sales guys do for you. You can make the fan shorter by making an arrangement 3 or longer arrangement 9. You pick your motor position, you pick your motor, you pick a disconnect if you need it. This is pretty standard stuff. You put a finish on the fan. There's a bunch of accessories if you want special L10 bearings instead of, I think we already have L10 bearings on it. You want it boxed, if you want a flow meter on it, if you want to write happy birthday mom on it, whatever you want to do, and a set of isolators, and you save it and you get a shop drawing out of that. So that's the fan. Now that's spending, what was that, 5 minutes on a fan selection? Oh man, if you'd have just rushed through this, you might not have gotten to the same point and known why you got to that fan. All right, so we looked at this. Even though we didn't pick a centrifugal fan, why would we include a 90-degree turn with our airflow? Well, so often in tight spaces, we end up with a condition like this: the elbow's too close, or someone did even worse where they put a box in it. All sorts of turbulence comes in. The fan doesn't do what it's supposed to do. Because of the turbulence, the static pressure isn't generated. So the balancer comes back with a report that says the static's low and the airflow's low. So what's the conclusion you're going to get from that? This fan's a pile. It's no good. Mark Nemeth, you're a lousy salesman. Stop selling me these garbage fans. No, that's not it. We have put the outlet, the inlet, the converging, the contracting, the expanding too close to the fan, and it causes system effects. Similarly, last week, if you were in the silencer class, hey, the fan's got to make up for these arrangements too. If you're not careful, too close to the radiused elbow, 1.05. No turning vanes, 1.1. Mitered elbow, 1.3. I don't know what contractors decide to do with their elbows in the field, but I know that every time they make a decision, it affects the fan. All right, let's do another one. Any questions before I move on? Bob, is there any chat stuff going on?
There are no chats at the moment.
So you want to? Should we ask if anybody needs a pillow? No pillows. We've all had this opportunity before. We're going to do summer ventilation. We're going to crank a whole bunch of air, put louvers on the side of the building, and we're going to relieve the heat from the plant. But that is a pretty big plant to be near a property line. Let's say our property line is at 100 feet away. Okay. Are we going to use a centrifugal or a prop? Who's got the answer to this? I see Mark saying prop. That's correct. And we can put most of our roof-mounted centrifugals come in a barrel, and then we'll look at a few different options for drives, but I think we're going to start with belt. Let's see. I touched on this briefly. So I showed you a few slides ago that backdraft damper, right? How much pressure drop that backdraft damper causes. With upblast props, they are tested with the butterfly dampers as part of the fan. So your fan curve includes the wind band, the butterfly dampers, that brace bar that goes across the top that has the latches that holds the damper in place. So when you're doing this fan, can you select it at 0 and feel good about it? You absolutely can. So let's go back here. We'll close out our inline fan. And we're going to select propeller roof. Oops, that's my habit. Sorry, guys. Group and propeller, upblast, propeller, roof, belt drive. Okay. So now we have fans with different props. So here's the X prop, the Triton prop, the E extruded prop, the A, the cast prop, blah, 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 blah. Who cares, right? It's a bunch of different props. Our max size is 95,000. Well, if I can't get at 200,000, I'm probably going to use 4 fans at minimum. So let's put it in, 50,000 CFM at, yeah, I'm on a call. Okay, now the first thing we're going to do, or one of the cool things that we can do, we'll sort it by zones. And let's see how bad it has to get for us not to be able to pick the fan. Here's, all right, 84 zones, pretty good bet. We're not going to get very far. But let's take a look at these 63 zone fans. 100 feet away is a long distance away. So what I'm going to do is right-click on this fan selection, and probably CAPS does this too. I don't know, but you can just throw this onto the sound calculator. So all it does is grab those individual octave bands, throw it in here, and saying, okay, at 5 feet away, what's my decibel level? Well, it's pretty loud. You need hearing protection for that fan. But at 100 feet away, do we meet the property line requirement, which we do not? So how much quieter do we have to get a fan that's going to work? Well, 64 didn't do it. Let's try 48. Again, right click, add to sound calculator, change it to 100 feet. Oh, man, we are still not there. All right, we're going to need to get down into the 30s, it looks like. Let's try. Now, I can also narrow this down. I don't want the motor to be serviced from below. I want to service it from the roof line. So I'm going to pick these, the TUB and the EUB. Those have the motors at the belt line. So let's try this. Let's try 44, see what happens. We can check that real quick. Sound calculator, 100. And we're not there yet. So we're going to have to go all the way to this 72 EUB and a sound calculator. And now we're within the parameters. That 55 is legit like residence code. So you may end up using this. So our octave band ones in the 90s, the rest of them are getting down into the upper 80s. We can make that work. You can monkey around with this by, if you want to just, like we were talking about last week, if you know you're 40 dB away, or if you want to stick like a custom, if you're going to throw a magic silencer in here and go, okay, it's 6, it's 13, it's 18, it's 24, it's 30. Now you can see how this is all going to affect your results going down. One thing to keep in mind, that those octave band levels are generally the inlet sound of a fan. Well, it would be nice to have the outlet sound of a fan, but you take what you've got. Okay, so we can save that one and do all that fun stuff. But that's the idea with what you can do with the software and the different models. You can monkey around and decide, okay, do I want the E prop or the T prop? Whatever, whichever one works out best for the thing. Okay. Questions on that? Looking good? Okay, a little bit trickier. Isolation room, 1200 CFM at 2.5 static. And so we're coming through a HEPA. Maybe that's even light. We sometimes do these at 4 inches. So what are our choices here? I did these selections already just to save a little bit of time. Now, give the contractor the opportunity to put in a mushroom fan versus the utility set. They will pick a mushroom fan every time because there's way more labor than putting this utility set on the roof. You have to pipe through the roof. You have to have ductwork that's sealed for outdoors. You have to have another set of rails, isolators, all that stuff. Putting a PRV on, you put the curb on, you drop the fan on the top, away you go. They're both centrifugals. So let's take a look. 1200 CFM at 2.5 inches. This is a high pressure upblast exhaust fan. We see these all the time for isolation rooms. Very stable, good selection. Kind of loud for a hospital. Now, could you silence this? Absolutely, you could. Next one, this is the next size up fan. Note how our turn down has gotten to be a little bit worse. Well, this is our turn down, but our stability has gotten a little bit worse. You know, we didn't pick up anything in the sound. Well, that sucks. Well, if we wanted it under 15, which I would feel a lot more comfortable about, we have become incredibly unstable. Plus, we have the variability of the HEPA filter. Well, this fan is not going to do it. So maybe this one, but it's kind of loud. All right, let's take a look at the centrifugals. Even though we changed the box, the results don't change that much. The number here is smaller, it's a size 80, but very stable curve, good turn down. I know it doesn't have DBA in here, so let's just compare to the other one. This is at 75 in, 80 out. This is at, what was that, DBA? DBA, 75 and 80. Here the 70 was too loud, so much for that. We got a little bit quieter here. By the time we get low enough for consideration, again, we're really, really tight on our stability. So one thing we can do, and I'll show this to you, is, and I'm not sure if this is in the engineering version of the software or not. What was that performance again? It was 1200 at 2.5. We have the option to change the geometry of the wheel and make it the area smaller. So when we make the area smaller, what does that make us do? It makes us spin the wheel faster, which will generate more static. So let's take a look at a normal selection first. And we just saw these. So when we got into trouble, it was this fan, the size 12, were too tight. Okay, close, back. Let's reduce it a little bit. Now our size 12 fan has a little more gap in it, and it's a little bit quieter than it was before. And how about our 13? Yeah, it's a little tight. So we can reduce it again. The industrial fan guys, they do custom wheels all the time. So it's not limited to just this third and 50% reduction. All right, so let's take a look. 120. Kind of loud, kind of loud. 135. Still kind of loud. We want to be in the 60s. Good gap here. All right, so there is some gap. The way they've positioned the do not select line is very conservative. We've dropped into the 60s on our DVA, and ultimately, this is the selection that I chose. 150 CPS, then you got to look on the shop drawings that it shows a 50% reduced width wheel. If you get a fan selection from someone at Airflow and we reduce the wheel, it's important to document it, because if you don't reduce this wheel and someone else gets the order, that fan is not going to be stable for where you need it to be. It's the same fan, different wheel. And changing out a motor or a fan wheel is not fun. So that's kind of the takeaway. It's another way, another selection available to try to improve the likelihood that you're going to be successful on the job. And there are some other tools in the software that are nice to use. I'm going to zip through them pretty quick, just so you know that they're there, because sometimes you use software, you go, I had no idea that that tool was in there. I wish I'd have had that. So let's see. Electronic publication. The engineering cookbook I use all the time for, like, let's see, I think it's, there's some pictures of, we'll get to the field. Where is this? Where is it? Here. I'll see this in the field and I'll say, look, that's a problem. And someone will say, that's not a problem. We do that all the time. At least it's in a book somewhere. You can say, look, I'm not making this up. These installation examples are not good. And you can pull the book up on your phone if you need to, because it's in one of their, they have an app for it. And just say, look, this is exactly what you did. And it says, don't do this, for example. All right, I use that a lot. This fan law calculator gets used usually at a really bad time. So you get out to the field, or you get a balance report from a contractor, and you go, well, we're supposed to have 2,000 CFM, but we have 1,500 CFM. So you have the balance report, and the brake horsepower is at 0.63, and you've got a 1-horse motor on there. I'm sorry, the static pressure is 0.5, and the brake horsepower is 0.63. And you go, well, I just got to turn it up a little bit to get it to 2,000. I've got a 1-horse, so I should be good. That's only 25%. Oops, 200 would be fine. Well, wait a minute. I only need 25% more air. I'm only 25% short. Why do I need a 1.5? I need a 2-horse motor now? Yes, you do. Yes, you do, because it's the fan law. CFM and RPM are linear. When you get to static pressure, it goes up by the square. When you get to horsepower, it goes up by the cube. And no matter how many times it gets said, people go, what? That's crazy. It's just better to show them. Just better to show them. And when you have a fan problem, this is the tool that you need to use. There is what is nice, I don't like going to Cook's website, which is brand new, to get catalogs. All the catalogs are right here. It's really great. That's what I use to make most of this presentation. Let's see. I didn't use the duct designer because I don't design duct. Sound calculations, I don't care what it is. This is a really nice tool. Just dump your, if you have an air handling unit fan and they don't have a software tool, you're trying to figure out what your distance to a neighbor is, or if you need to put up a barrier wall or something like that. This is a really good tool to use. It's pretty easy. There is one other one here. There's if you're going to make a case for fans, so you got one fan and it operates 24 hours a day and 365 days a year, and your mixed flow fan horsepower is 1.3 and your centrifugal fan is at 2, and your motors, you're going to guess, are at 95%. I don't know if that's a good number or not. And you're at 10 cents. There's your annual cost for energy. I'm sure you guys have a tool like this, but we use it pretty regularly. And sound calculator, psychometric chart. Where'd that go? Oh, it's over here. This is a real quick, if you're doing ERV calculations and someone gives you a relative humidity and you need to calculate wet bulb or something like that. I'm sure the engineers have better tools than this one, but as a rep we don't, so we use this one pretty regularly. And let's see, we did that. There's a chemical resistance guide in there, and finally, let's see, export. Your sales person can export the actual Revit files, job specific, which isn't anything new for most of us, but it is available. We don't always get asked for it. Some engineers just prefer to download the library, but if you want a specific schedule for Revit, you can get it right off the job. So with that, we are coming up, we are at time. So are there any questions at all? Please.
In the chat, you've got a question.
Oh, yeah?
No, it's not a question. It's just a share.
Please read it. Unless it's Tom, if it's Tom's a bad presenter, then
it's from Josh. Would you care to?
I'm with GBA. We use sugar engineers all the time for if you need a quick psych reference. If you're just, it's just a browser-based psych chart essentially, and you can type in. Just thought I'd share that when you were mentioning the psych chart.
Good. Okay, excellent.
It's a great conversation starter at parties.
Yeah, totally.
And I would add this. So if you're a contractor or a consulting engineer, you might pick 20 or 30 fans a year. For the folks that work at Airflow and candidly other fan reps, we're making 500, 600 selections a year based on what we're estimating, projects we're designing, whatever it is. Do not feel bad to ask, or at least make the selection. Say, I don't know, what do you think about this? Because look, there's no, it's not like when you went to engineering school, they taught you how to use the fan selection tool or how to read that book. You probably figured out what you know on your own. So ask. Odds are you're going to be right, but if we catch something that you might have missed, oh man, it can save a whole lot of heartburn. The very worst fan problems are the ones that are close. You know, it just barely doesn't work. And had we picked one size smaller, had we picked something just a little bit different, oh man, it can solve so many problems. But if you're a little close on that, close to that do not select line, or there's some system effect that you're not aware of, oh, the 4 trips to the job site, the meetings, the angry customers, the angry owner, all that is so not worth it. So we pick these fans to stay out of trouble. We don't want you in trouble, and we certainly don't want to be at that job site when there's something that's going wrong. Do we support all those? We absolutely do. But and sometimes it's interesting to solve a tough one, but they're too expensive. The fix is always way more expensive than the fan. Take a few minutes, a little bit longer, and try to find the perfect fan for the job. There are no bad fans, just sometimes bad selections and installations. So, and if there are no questions, then thanks for coming. You know, I think I forgot to record it, Tamara, but oh no, we're recording. Yes. Tell your friends. That's all I got, guys. Thanks for attending, and hope to see you all in the flesh soon enough.
Thank you.
Thanks, Tom.
You bet. You bet.